Hello everybody and welcome to the live stream for CS 135 day 1, even though we had a day 0, but this is day 1 because we were going to actually start to learn stuff today. And so, all right, I moved the chat up here, so now I got to look up there to see the chat. But how many people do we have, and can everybody hear me okay? Do we get good audio and everything? Because I had to have a situation where I had no audio before. So say something on chat. Can hear you fine. Okay, good, great. So since this is the first time that we're doing the live stream, let me tell you a couple of things. First of all, actually, let me fix that weird glare. There we go. Okay, that's better. A little bit. Oh, yeah, good point. I can bring the microphone closer, and then I should be better. Okay. Yes. So thank you for telling me about the microphone. So now we should be pretty good. Okay. All right, so let me go ahead and switch over here. Perfect. Okay, so today we are having our live stream at 7, so I'll go ahead and put the 7 in here. And tomorrow we'll have it at 7 as well. I did go ahead though and publish a poll on Discord, a Google poll, so that you guys can vote on a better time if you want to have a different time for the lectures. Otherwise, I'll switch to the morning in a few days. And yes, good evening to you guys as well. I am recording the lecture and it will go on YouTube, and they will always go on YouTube. So yes, anything, if it cuts off, if you can't make it to the lecture or any reason, you can go ahead and go on YouTube. So, okay, so let me tell you how to interact with me, since a lot of you guys, probably the first time you're going in here. So basically, if you have a question, you can post it on chat and I'll get back to you. If it's something complicated and you'd rather do it by voice, I can hop on the Discord channel and you can talk to me there. And there might be a slight delay on the stream as it goes on. Like, I think historically it's been almost a minute in the worst case. However, if you do see a bigger delay, you can refresh, and sometimes that helps out. As what happens is, if your connection kind of lags behind, it'll actually it'll pause the video to buffer it, but then you'll get a bigger delay. And right now I have it set to the least delay possible. Also, if the stream goes randomly offline because of the internet, don't panic. It usually only lasts a few minutes, like 2 or 3 minutes tops. This has happened in 302. Usually it has come back up. And if not, I will keep you up to date on Discord or even on Twitch, because I can use it on my phone and I can use data. So that way, if unfortunately like the internet just totally dies, then you know, we can figure that out. So cool. Let's see how many people we got. 15 viewers. That's pretty good. It's not bad. I actually wasn't expecting that many people, so I'm pretty happy about that. So good. Okay, well, let's go ahead and actually start the material. Like I said, if you have any actual questions that you want to ask in voice, remember, it's been recorded, so your voice will be recorded and posted on YouTube. So if you would like to do that, just post it on here and I'll hop on Discord. I used to always just be on Discord idling, but that's just a little bit of extra bandwidth that I'm using on Discord, which takes away from the bandwidth that I can use on the lecture. So I don't want to push my my lecture out. You guys are doing the point thing. That brings a good point. So I set up a couple of point rewards, which are like extra credit. So you can get extra credit for attending the live stream if you achieve channel points. So there are other things that you can do for fun, like that, like Sam just used that thing. But you can save your points and use them as extra credit, and that can help you out in your homework assignments if you attend lecture. It's completely optional, but it's available to you if you want to do it. So I'll mess around with the values of that in a little bit. But yeah. All right. Hello, everybody. There's a TA. Welcome, TA. Cool. How can we redeem them? I'm not sure. Ask Sam. He probably knows better than I do. I think you have to earn them first. He has them because he was watching the 302 lecture, so he probably hoarded the points over, and that's why he has them now. But I think you earn them over time by just being active in the stream, which means interacting, like posting, and just having it open. I think you can farm points by just minimizing it. Of course, why do that? I mean, I might as well just watch it at that point. You know, you don't have to be 100% putting attention to this. You can put this on a side monitor if you want. But you know, there's that. Yeah, so you just earn over time by watching, but I think you get more if you interact. I'm not sure. You can definitely Google it as Twitch channel points. Also, if you don't have a Twitch account and you're watching and you don't want to make one, you can also post your questions on Discord. And I sometimes I'm bad at this, but I try to keep track of the Discord text chat under the CS135 video lecture channel. So you can ask questions there too. Those can also be semi-anonymous because I will not call you out by name or Discord name per se on that. So if you have a question you don't want to show up on the stream, because as you can see, we're up here, we got all chat showing up. The reason I set this up was because in the past, when I was recording, it didn't record the chat. So when people would watch the replay, I'd be answering. I mean, I typically do a good job of like reading the question out loud and then answering it. But then people would sometimes still be confused about it, especially if there's like a discussion going on in the chat. So I went ahead and put the chat here. So that means it is being recorded as well. Also, something I'll do this time around just to have extra safety is once I see a couple of people show up regularly to the live stream, I might make you guys mods so we can control in case random people raid us. Because last semester we had like people from like a different university raid us, and it was kind of distracting. So yeah. Anyways, do you think it's better to take hand notes? I don't know. I mean, anything I say is being recorded. And the screen is there so you can screenshot. So I don't know if you necessarily want hand notes or not. You can do whatever you want, of course, but I would focus more on putting attention to the lecture and knowing that whatever I'm showing here is there for you. You can rewatch it on replay. You can take a screenshot later. Maybe take notes on something that I say and I don't write down in the case that I say something you think you may want to remember. But other than that, I'd say, although the one exception to this is if you're trying to go for that extra credit of turning in your notes at the end of the semester, in that case, then yes, you want to write notes out. That's the one exception where I'd say, well, yeah, you should be writing down the notes. But okay. All right. That's enough of an introduction. Let's go ahead and jump right into some basic material. And so how I'll do today is I'm going to give you a brief overview of programming and problem solving. Maybe hopefully it takes us like 20 minutes. And then from there, we're going to jump in into showing you a little crash course in Linux and the SSH and SCP and all these commands, the ones that I told you to watch the video on. Hopefully you guys watch that video. That way, even though I'm going to go over the same stuff, you know, maybe you got like 20% of the video's content already. So it should be a little bit easier than just like fresh out. But if not, the one good thing about me showing you all these Linux commands is that you can rewatch the video later in case you forget them, because I don't expect you guys to just like, I tell it to you once and then you just remember it forever. You know, it comes with time. So, oh, there's that one guy. I never found out who that guy was, although I have suspicions. But yes. Okay. So, and then after that, I will show you how to do a basic Hello World program. And I think that will pretty much take us to almost 2 hours. But if not, then we'll just keep going and cover as much material as possible. I'd rather be ahead than behind so that we can spend more time with other material than with this basic stuff, you know. I mean, the one thing about programming that you should know is that I could show you all there's to it, but until you practice it a lot of times, you're not going to become good at it. It's like you could watch a tutorial on how to be an athlete, like how to be like an amazing football player. But if you don't actually play the sport and practice it a lot of times, then your theory is going to end when you jump into that field. The only way that you're going to become good is with practice. Practice makes master. And that is 100% the same way with programming. I could show you how an if statement works. I could show you how to do this, how to do that. But until you practice it a lot of times, is it going to become second nature? Same with the language, not just with the programming language, but a normal language. You're trying to learn a different language, you got to practice it. I mean, I can tell you like, hello is hola in Spanish, and you could know that, but if you don't practice it, you're not going to remember it, and you're not going to be able to make it flow. Oh, we got all the 302 people. That makes me wonder of the people that we have on, how many are actually in 135 and how many are 302 people? Because then I'm sad now that there are very few 135 people. I'm happy you guys are here though, but yeah, you know, there's that. If we do the coding, do we do it in the Ubuntu terminal? Yeah, if you want to code with me, you definitely should. I'll show you right now the setup that I have. In fact, let me briefly jump into that. The reason I'm looking up now is because this monitor is now the Ubuntu monitor, and so that's why. Let's go ahead and try that. So I call that zoomable. We just want to learn 1.5 all over again. Funny. How is that, by the way? Like, how is that font size? Because I can make that bigger or smaller. So can you read that? Can you read that? Like, is that a readable font size? Yes, sir. Okay, good. Looks readable. Good, good, good. Okay, so that's what I'll use. I could make it bigger, but I'd rather make the actual terminal bigger so that we can show more text, you know? Cool, 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 cool. So it's actually pretty zoomed in. To me, it's like half the size because I got big monitors. So I didn't want to make the font super big because that's just, it's not cool. You know, it's cancer. But yeah, okay. So cool, cool. But let's just jump back to this first, okay? So whenever I want to use the board per se, what I do is I will use an iPad, and that way I can draw in that. Now, in the past, I used to make these PDFs available on the Google Drive. I could probably still do that. It's just going to take me time to set up inviting everybody. So maybe I'll just post I'll figure out a way of making them public. Either way, you can see it on the video. I don't think there'll be that much that we'll actually write on these things compared to other classes like 302. So, okay. So, the most basic thing, since this is computer science 1, but in reality what this class is really about is learning how to program. So let's go ahead and define what is programming in the first place. Like, what is programming? And I do have a way of setting up polls on Twitch. But for this one, let's just go ahead and post on the chat, what do you guys think programming is? Or better yet, what is computer programming? Because I guess programming could be used for things that are not computer based. What's a skeleton code? That's a nice question. You know, you'll learn when the time comes what a skeleton code is and how it's such a desirable thing that you don't always get. Ask the 302 people. Editing, creating applications. A computer program is editing and creating applications. Programming, computer programming, editing and creating applications. I think that's too meta. I think we gotta focus it a little bit more. Written instructions for a computer process information. I think that's a much better definition until you run into an error. Basically, I like that one. I like that one. Like the written instructions for computer process information. So I'd say programming is definitely instructions, and it's not just any written instructions, but it's a sequence of them. So it's a sequence of instructions or sequence of steps for a computer to follow or the computer to follow. Yeah, that's writing. Cool. So computer programming is a sequence of steps for a computer to follow. In fact, I'd say programming without the word computer, it would be just a sequence of steps. Usually, yes, they're written, but you know, if it's not computer programming, it's just normal programming, I guess you could tell them to people. And so a computer program, by the same token, is going to be a sequence of instructions performed by a computer. So basically, running all the sequences that you've made. Let me take my watch off because it's not letting me write comfortably. I forgot about that being a thing. Okay, here we go. A sequence of instructions. And I'm trying to write as fast as I can without making it not legible. So it's a careful balance that I have to reach between making something legible and not legible. But I do try and always read out loud what I write, just in case that something's not legible for the people that are not here. And you can always, of course, ask, you know. Slap, slap. Okay. Anyways, okay. But we keep using the word computer. So I think it might be a good idea to define what is a computer in the first place. So what do you guys think a computer is? What is a computer? It's a very, I mean, the class is called computer science, the degree is called computer science, but what is a computer in your guys' eyes? Like, how would you tell someone, like, how would you tell Captain America what a computer is? Because Captain America is like, what, from the 40s, so like, he doesn't really know, you know, what a computer is. So how would you tell it in your own words? Go ahead and write that out. We got 26 viewers now. That's pretty good. My guess is that there's a little bit of a delay, though. Look at you guys wasting your points on not the extra credit. A machine that receives information, processes information, and returns information. Oh, wow. We had like a flow of people posting. So that's definitely because of the delay. So we just had like 4 people post at the same time. So there's probably like a 1-minute delay, but it's okay. It's okay. All right. So we got a machine that receives information, processes information, returns information. I like that. Then we got a device that can take input and give you outputs. Basically the same thing as cosine tan said. And then we got device that inputs alpha data. So we're getting a common pattern here of input output. Good, good, good. And then a device that manipulates information and stores data. Okay, interesting. A device is essentially God. I don't know about the last one, but I agree with the general consensus here that we're having sort of a 3-step process. We're having in, then we're having something happened to that data, some magic, and then we have an out. And as Captain America would say, it seems to be working on some form of electricity. That's what he says in Avengers. So let's go ahead and throw in the term, maybe not electricity, but electronic. So I'd say a computer is a programmable electronic device that is capable of doing those 3 things that you guys basically said. So we got the in, the middle, sort of the manipulation, the processing, as you guys called it, and then the out, which is the returning. So a good term for those that is typically used is storing, which is that input part, processing, which is that middle part, that manipulation, and then of course the returning, which another famous term is retrieving, kind of like a dog, you know, retrieve the stick. That sounds kind of aggressive. I don't know why, but yeah. The shock box. I don't know what that means, but okay. But anyways, yeah, that's pretty much what a computer would be based on. And of course, the one fancy term there was programmable, but we kind of talked about what that is, right? So in a way, programming, computer program, those are all kind of interconnected. Okay, so now let's go ahead and move in to sort of what makes a computer be, you know, what it is today. And that's going to be based on 2 things. One of them is going to be the physical stuff, and one of them is going to be sort of the not so physical, but electronic stuff. A better term for these, of course, is hardware and software. So a computer is made up of hardware. Those are actually going to be your components, the physical components, and software, which is actually all the computer programs that are executed by the computer. Okay, so let's talk about the different pieces of hardware that we have. How about you guys tell me what makes up a computer? Like what pieces of, like, you know, look down or up wherever your computer is. I guess if you have a laptop, it's kind of harder to see that. I have one of those computers that has a glass so I can see inside. But what are the main components, physical components of a computer and the surrounding peripherals? And we got 1 already. We got 2 already, I suppose. So we got the motherboard, the holy motherboard as we called it. We got the CPU, the GPU, pretty good. We got the screen, the motherboard. Well, a mother, somebody said already, but the screen. Good, good. So let's go ahead and put them down. So we got CPU, as somebody said. We also have, somebody said the motherboard. So yeah, we'll put it in here, motherboard. Then we got GPU. Then somebody said the screen. What else did the guy say? Screen, GPU, CPU, processor, RAM memory, main memory. Yes, that's very, very, very important. We've got memory. And not just any kind of memory, but we got RAM, which stands for random access memory. That's a 219 thing, so don't worry too much about that part. But yes, that would be considered main memory. And we also have secondary storage. Somebody called it long-term memory. I wonder if that is what they were thinking of, but somebody else did say it in a better way, which is a hard disk. Yeah, so the hard drive. So our secondary storage tends to be something that's not in the main memory, which can be a hard drive, HDD, hard drive disk, or nowadays, you know, SSD, solid state drive. Cool. RGB lighting, of course, being the most important. I agree. You have to have RGB lighting because otherwise the computer doesn't work. It works faster when there's RGB lighting involved. RGB stands for red, green, blue, by the way. So, okay, so let's kind of classify these into sort of the main things. So really, when people typically talk about hardware, they talk about CPU and main memory as one thing, sort of the internal, the important stuff. Then you got your secondary storage, which is all the hard drive stuff that I was talking about. This is how the book says it. And then we got our I/O devices, which is input/output, which is going to be input's going to be the keyboard and the mouse, and the output's going to be the screen, the speakers, just about anything else that comes out. I mean, actually, a microphone would be an input device, and so would a webcam. Another output device other than a monitor and a speaker would be maybe like a controller's rumble pack because it vibrates, or what else? Well, if you have like a VR headset, you know, would be the video again. So yes, mouse and keyboard for the inputs, and then screen and speakers is the most typical outputs. But a printer is technically an output device. You know, it prints stuff. It just doesn't print it to the screen. It prints it to paper. You know, back in the day when we used paper. Now we use the shells. If anybody gets that reference. So, okay, cool. So let me draw you, although I could draw you, but I think I'm better to show you because I don't want to get artistic here. Something that's kind of, it's more 219 than anything, but I do believe they do mention it in 135. So it's called the von Neumann diagram. Let's see if there's a good one here. Oh man, these all look technical and boring. I guess I'll have to draw it. I think the book actually has a really nice picture for this. Yeah, I could show you what I'm looking at, but they're all boring diagrams and not cool. There's like one that looks cool, so. Okay, so I guess I'll get artistic here. So there's this guy whose name is von Neumann Diagram, and he's a pretty big deal in the computer science world because he's one of like the OG guys, and we'll learn more about him if you take 219. But one of the things you should know about him is he created the modern computer and how it's organized. So yeah, the von Neumann diagram is basically a way of representing these things that we wrote. And I have here in front of me a couple of diagrams. Now here the diagrams are literally just squares with titles, but I'm gonna try to do it in a prettier way. Let's see, what's a good one? Yeah, I guess this one. Von Neumann Architecture. So this is called the von Neumann Architecture. And von Neumann Architecture is how all our computers nowadays pretty much work. And that is, in the center here, oh, I gotta get artistic. It's gonna be your control unit. And that includes the motherboard and the CPU, essentially. Actually, I'd say the motherboard kind of connects all of these, but at least the CPU would be there. The GPU, I'd say it's kind of there, you know, actually nowadays, how things are set up. So maybe CPU and GPU are kind of there. And then we have this arrow going back and forth that connects So in fact, because the arrows go back and forth, I'm just going to, for all of them, I'm just going to make lines like that. And then we got our RAM. So that's our RAM, which is memory. However, it can also be, I didn't want to do this, but I was forced because there's no cool pictures. It can also be your secondary storage, okay? So in general, we got memory and control unit. Those are the big title things. And then on the other hand here, we've got, I almost wanted to do something super old school like that. That's like a TV, but no, we're not at that age anymore. Okay. Imagine just having one monitor in 2020, but this guy does, so yeah. Okay. That's not too bad, actually. I'm kind of proud of that drawing. However, it's old school. So, yeah. Okay. So, yeah. So, and then, of course, you're watching me there. So, I guess I'll draw myself. There we go. Okay. So, this would be the I/O, which, by the way, I guess I should write it at least once. It stands for input-output when I say I/O. And, of course, we have mouse, keyboard, monitor, and speakers, which is what I said. Could also be, I suppose, a controller, but who uses a controller nowadays? And so that's our third category. And then technically we also have the ALU, which is kind of part of the CPU nowadays, but back in the day, the ALU was the arithmetic control unit, I think. What does this stand for? Yeah, I believe that's what it is. Like arithmetic, Google time. What is the else? Logic unit. There we go. Arithmetic logic unit. So. It's the one that does math. There we go. Whereas CPU, by the way, stands for Central Processing Unit. So I didn't want to do this, but I was forced to do the drawing. So there we go. We got our drawing now, immortalized. Back when the aliens look at us, they're going to be like, imagine a monitor that has depth to it or something. I don't know. But yeah. Anyways, I really, for some reason, want to draw the RAM green. So I'm going to take the time to do that because, I don't know, it just feels like it should be green. Like, I mean, is my RAM green? I don't think it even is. It's not. It's red. But back in the day, all RAM was green. So because typically chip boards are green, right? The base of them. But yeah, it's a very nice build. But yeah, so basically, this usually all these things are typically found. In fact, I'll use a different color for that. These are typically found inside the box that we call the CPU. So most people just call this the CPU. But technically, if you want to be pedantic about it, you know, the CPU is just going to be the actual chipset, the Intel or AMD chipset. That's going to be actually the CPU. And inside of the CPU, there's usually the ALU. They're not separate anymore. However, in a phone, you know, everything's super compressed nowadays. So, yeah. Okay? So, good. We got there. I might just save that drawing for 219. So, yeah. All right. Okay, so that's all the hardware stuff. Okay, so we got hardware. And I know there's a lot of really basic stuff, but, you know, kind of required to cover it. So, some weird things happening here. There we go. Okay. Then we'll get to actually interesting stuff. So, okay. Now we got the other side of the coin, which is, of course, the software stuff. So that's the stuff that we as computer scientists deal with. We don't deal with the lower tier making actual hardware stuff. That's the computer engineering people. If that's what you thought you do in a CS degree, then you got to switch majors because we don't deal with that stuff. We deal with the software side. Hardware stuff is the electrical engineers and the computer engineers. Computer engineering, I'd say, is more like a hybrid. It's like half-half. But the real hardcore people, that's why I make fun of CP people, because CP people are like a jack of all trades. They're not even that specialized. Like the electrical engineers are real hardcore people. So if you really want to be hardcore into the hardware side, electrical engineering is definitely the field. whereas computer science is the software side, and CPE is like the undecided side, like they're not sure what they want to be. So that's why I'm like, you know, go one way or the other, or at least dual major. Don't just do CPE, you know. So don't listen to those people with their CPE propaganda. Yes, CS is superior and it's better than CPE. And this is being recorded for eternity. So, okay. All right. So, okay, so what is software, though? I keep saying software. Where I think I said it before, but these are going to be your programs, which, again, are the set of instructions to be executed by the computer. And then the programs are going to be designed to control the computer. And it's very important that we control the computer, right? Because if we lose control over it, then we get Skynet and Judgment Day, right? So we got to make sure those programs are well made. Actually, more seriously, if you don't make them good, then the computer doesn't work. So software is kind of split into two main kinds of software. We got system software, and we got application software, more commonly known as apps. So system software are going to be the ones designed to control the computer, as I said. And within that category, we have OS, which is operating system. And that's going to be a set of programs that control the overall activity of the computer and provide services. So control PC, I suppose to abbreviate, provide services. What do I mean by service? Well, think about all the basic things that Windows or Mac or Linux do to you. They allow you to have a way of accessing your files. They allow your computer to communicate between different components, such as like you being able to save data to your hard drive and being able to retrieve it for later usage. They allow you to run, say, Firefox or Google Chrome, which is what you're watching this video on. And so that's going to be an application software, because those are going to be programs designed to perform specific tasks. Specific tasks. Okay, so these are, for example, Firefox or Chrome. Those are going to be programs that are designed to, for example, browse the web. And of course, nowadays, it doesn't have to be one task. Like a browser, you can watch videos on too, right? You don't have to use a separate program for that. So basically, it doesn't have to be like just one task, but it's a set of tasks, a set of specific tasks. Like I don't use my browser well, see, it's kind of tricky because I want to say like to draw, but then again, you could have a sub program within the browser that can draw. So I can also say I don't use my browser to change my temperature, but then again, you can have a program that does that, right? But at least it connects you with other things. But let's go ahead and pick something better. An example of a program, of an application software, is like a video game, you know, Fortnite or Valorant or CSGO or CSVO for those of you from 302. So these are programs that are designed to play games. You don't use them to file your taxes, right? So you also don't use them to copy stuff into your hard drive. Or Warzone, yes, that's that one too. We don't talk about League. That's not a real game here. So yeah, get out of here. Where are the Valorant drops? Oh yeah, that's right. We can. Well, that's gone now. That's not even the thing anymore. But yeah, we did have Valorant drops at some point, and so one person actually did get Valorant from the lecture, which was great. Yeah. So yeah, okay. But anyways, so the OS are going to be the sort of controlling software, and then from there you got your applications that do individual things. But you need the entire OS to be able to do the other things. With no OS, you wouldn't be able to open Firefox because there would just be no way. With no OS, you wouldn't be able to use your RAM because Firefox wouldn't know how to communicate with the RAM or the hard drive or the GPU. Like, okay, Warzone. You're trying to play Warzone and the game has like 200 million gigabytes of data, right? The OS takes care of telling Warzone like, yo, here's my hard drive. Please be nice with it. Do what, but here it is, so that you can store data. It also tells Warzone, Here's the RAM. This is how much I got available. I can spare. Let's say you got 16 gigs of RAM, but you're trying to play Warzone while watching the lecture. So the lecture is taking like 4 gigs of RAM, because it's Chrome. And then so that gives you 12. But the OS itself to operate maybe needs 2. So you're left with 10. So the OS tells Warzone, yo, all I got are 10. Here are 10. That's it. I can't give you any more. If you try to ask for more, I'll shut you down, which is crashing. So basically, Warzone's like, okay, I got 10. How much hard drive can you give me? I want more. I want more. I want more. Because, it's 200 gigabytes of storage or 100 gigabytes of storage. So the OS is the one that's organizing the mess of the programs. You can think of it like you got 100 people. They're all different programs. They're trying to do their thing. All they want are resources. They want memory. They want, in both RAM and hard drive, they want processing power because they need the CPU to actually do the math computations. In Warzone, when you're shooting a bullet, it's got to calculate the trajectory of the bullet. Or when you see a light, it has to do the ray tracing, which is also trajectories. All of this requires computational power for both the GPU, which is floating point units, and the CPU. And so all of that needs to be organized, and the CPU has to have a way of scheduling and saying, okay, I'm going to give you a little bit of time, you're going to get a little bit of time, and so on. And it does a lot of work to organize them. If it wasn't there, then you would have chaos, and no one would get anything done. So the OS is very, very important to the point that there's a class dedicated to it here at the CS department, which is 370, which is operating systems. And so, that's pretty much my own where I'm going to stop talking about OS. But if you want to know more, then you can definitely take that class when the time comes. Or if you're a CS major, you will have to take that class. So no choice. But yeah, okay. So hopefully that kind of gives you an idea of the difference between the OS and the application software in general. So what is a system software that's not operating system? I'd say it would be like a driver. That would be probably system software that is not an operating system. What's a driver? Drivers are specific programs that allow something like your mouse to communicate with your computer. Am I going to fix the quiz situation? Yeah, I'll take a look at it and I'll see why it's not letting you retake it. By the way, is it doing that for both? Like for both quizzes or just the one with the lockdown? Anyways, while you answer that question, yeah, I need to get 1,000 YouTube subscribers. So guys, subscribe on YouTube because that way I can actually do mobile streams, and that's what I want to try to do for the fall semester. I want to be able to live stream from the tablet directly while I'm teaching class, so people at risk can stay at home and just watch the lecture from home or from the class. Yes, it is for both. I can definitely fix the one without the lockdown. I have no idea about the lockdown one, but I'll fix that. I'll do that after the lecture though. I don't want to waste everybody's time watching me try to fix it. But okay. So next we're going to talk about the program development process. Okay? So this is how do you actually make a program? Okay? How do you make a program the right way? Because there's a right way and there's a wrong way. The wrong way is just sit there and start coding crap and then just hope it compiles and hope it runs. The right way is a sort of a plan, sort of like brainstorm, decide on a plan, sit down, program, and then verify. That's the right way to do it. So let me actually write that down. So this is the right way to write a program, okay? Which probably nobody does, but we all say we do. Okay, first we got, I guess who would do this? Maybe like a big company because they actually have quality control. So we got analysis and specification as the first step. Then we got our general solution, and I'll tell you more about these. Let me just write them down first. Then we got verify, I guess. And then, I don't have it written here, but there is technically one more sort of, nah, I'll leave it like that. I'd say the second one is the bug fix, but yeah. Okay, so the first thing you should do when you're trying to write a program, and of course a program is like, don't go super hardcore into like Warzone, but maybe you just want to write a program that is a little calculator, And I think you will. That's one of the assignments that I make you do as a calculator. Assignment 3, I think, along with the quiz, the week quiz. So, yeah. So, okay. So, you need to figure out what do you want your program to do. And this is something that I actually do when I'm doing your assignments. I actually have to sit down and say, okay, what am I trying to actually achieve here? Like, what is the purpose of the assignment? I want to have them practice if statements. I want to have them practice this. I want to practice that. So I have to analyze and sort of write down some sort of scraps of like what I want to do. Like, do you want to program yourself a girlfriend? That's what you're saying. So yes, you would have to say like, what characteristics do you want in your Android? So you have to write a list down of everything by defining the problem and what the solution must do. Okay? From there, you need to develop an algorithm. So that's going to be kind of like define the problem, develop an algorithm. Now, what is an algorithm? Might be a word that you've never heard in CS135 level. That's a possibility. So I have a little definition here that I stole from the book, I think. So it's a step-by-step procedure for solving a problem in a finite amount of time. By the way, a quick disclaimer. I actually took CS135 in UNLV under Lee Mish, who is now a retired instructor. Was a great person and very inspiring. I probably, you guys joke, but I don't think I'm anywhere going to be up in her level of abilities to teach and everything. She was great. And I did keep some of her notes. And I wish I could share those, but I don't think I can without her permission. So I am referencing some of her notes. So, but some of this stuff is coming from that. I wish I could just post them, but like I said, they're not my notes. So sorry. But she was great. She was great. Lee Mish was her name. Like that. Oop, with an H. She's a legend. She taught like 5 sections of 135 at the same time and things like that. She was hardcore. I loved her. I mean, I know some people had issues, but that's just because, you know, teaching styles. I clicked with her teaching style. Some people don't. I did. So yeah, she's great. I'll erase her name just because I don't want her to be on the internet. But you know, I think she retired to Colorado, so I'm glad she's retired. Hopefully she's okay. I haven't talked to her in a long time. So, anyways, okay. So, anyways, an algorithm is a step-by-step procedure for solving a problem in a finite amount of time. 2 big things here. Step-by-step is dangerous. What was her teaching style? She was very strict, like you to the dot. Like you did a little tiny thing wrong, you'd lose a lot of points. But in a way, she was like teaching you discipline in coding, which is something that is very hard to instill on people. Like, I'll have a hard time instilling that on you guys, like trying to make you guys have a good coding style and etiquette. And the only way to do that is like hardcore, like military style coding, you know, like buried to the dot. Like you have to code in a test, and if it was slightly off, you lose a lot of points. But that's good at this level because it really teaches you to be a good coder and to be clean, you know, like tidy in your code. So I think what she did was right, but she took a lot of flack from it because a lot of people didn't like how strict she was, you know. Yeah. Basically, I guess she was like the Marines version of coding. So I can see why people didn't like that, but ultimately it's good for you, you know. It's like a little discipline is good for you, I suppose. I think that should be her slogan. So yeah. But anyways, I don't want to get too sidetracked, but with her. But I wish she was sometimes here because I would have loved to sit in her class again or something and learn more about her style. But anyways. So the big thing here with step-by-step is you got to be careful about that, okay? Because if I tell you, like, write a program that plays Warzone for you, like an aimbot. Maybe let's write an aimbot for Warzone, okay? Because we're trying to do better in the game. Here's the thing. You can't just be like, step 1, ask the user how hard the aimbot wants to be. So, like, how hard it locks on. Step 2, have the aimbot lock on. Step 3, profit. That's it. That's not very good step-by-steps. Computers don't understand those steps like that. You have to break those steps into tiny little steps that the computer can actually understand. And that aimbot is going to be like a billion steps. Like, it's not as easy. It's going to be like step one is probably inject into the DLL for the program. And then from there, you're probably going to, which of course is a bunch of steps of its own. And then from there, you're going to try to get some geolocation data of the enemies. And then you have to do some sort of path finding, not path finding, distance finding to find out where you want to aim and where you're aiming. And then you're going to have to calculate the motion that you have to move to aim. And then you're good. But before, you got to find what an enemy looks like. So that's where the injection part is useful, et cetera, et cetera, et cetera. So ultimately, you will have a lot of hard time if you've never programmed before understanding this step by step, but you have to break your steps down super easily. Let's think about an activity that we do today. Eating breakfast, okay? And I'm not even, let's say you're gonna eat a steak and eggs, the NASA breakfast, okay? I'm not even saying you're cooking it, you're eating it. What are the steps to eat an egg and steak breakfast? Step one, let's say you're sitting already at the table, okay? That's your starting point. Step one is pick up fork. But that could even be broken down further, like stretch hands, move hand certain degrees up, angle it down certain degrees up, fold fingers certain degrees or whatnot, okay? You can go even that much, but let's say that you can just pick up the fork in one step, okay? Step two is pick up the knife. Again, that could be broken down into a ton of steps, which if you can think of our hand as a bunch of little motors and angles to move it, you know, you have to like move it down, maybe turn it a little bit, close fingers, which is closing 5 fingers, different steps. And within the finger, there's like different joints that you have to deal with. So you have to do a bunch of this stuff just to pick up the fork. Next, you have to now configure the movement of the fork and the knife to hit the steak and chop it open. Oh, that's not even assembly. Assembly would be like send the signal to activate the servo for X amount of time, which represents moving at X amount of degrees. That would be assembly. But yeah, so cut the steak open. Open, that sounds savage. Just cut the steak and then lift it up, put it in your mouth, then activate chewing maneuver, you know, open, close teeth, a certain amount, you know, 20 times, because I get to say chew 20 times before you swallow. And then as you're chewing, you want to move the steak around so that you're chewing different spots. Otherwise, you're just going to split it in half and not chew anything else. And then after it has been saborously disintegrated in your mouth, melted in your mouth, then initiate swallowing process, which involves, I guess, moving your tongue and activating certain muscles in your neck or throat and putting it in there. And then your esophagus moves like that to push it down to your stomach, and then begin digestion procedure, which is an entirely different program. There's a lot of tiny steps. And like I said, I could break them down even further into even smaller ones. This is the mentality that you have to think about when you're programming. You have to think in more than just big steps. You have to really break down into the tiny little steps to be able to program successfully, because those are the only ones that are available to you to work with. So that's the tricky part about generating an algorithm. You can't just say like, step one, eat. Step two, digest. Done. No, you can't do that. You have to go up to the minuscule details to get this working. Maybe in there we have to throw in the don't forget to breathe function. Otherwise you will die. And not just don't forget to breathe, but now you got to synchronize the breathing and the swallowing so you don't choke by trying to breathe and swallow at the same time, and then it's GG. So you got to be super, super detailed about all these things. Now, that would be what I would think about a semantic error, not a syntax error, because a semantic error would be where you forget that you're supposed to breathe and swallow at different times. And then in this case, your segmentation fault or your program crashing is you trying to breathe and swallow at the same time, which results in your unfortunate and early death. Or at least somebody doing the Heimlich maneuver on you to get it out. So it sounds easy when I tell you, oh yeah, step-by-step procedure for solving a problem. It's not easy. The second part is more of a future topic, 302 topic, finite amount of time. It's not enough for me to develop a process of eating. If a process of eating is going to take me 24 hours, Because then I don't want to sit down to eat for 24 hours just to eat a steak. I want to be able to eat it in 5-10 minutes so I can go and do other things in life. So being able to actually eat a steak within that limited amount of time is a whole different thing. For this class, though, by finite amount of time, we mean so the TA can grade it in a decent amount of time. But in future classes, when you get to 302 and that, you actually start to analyze, how certain algorithms are faster than others and in a finite amount of space. So yeah, you don't want to be the panda eating. So yes, big preach, but it's important stuff. And if I don't tell it to you now, I don't want, go into it with the wrong mentality. Finally, we got the verify part. The verify part is, of course, the hardest part, to be honest with you. Not the algorithm step, to be honest. I mean, actually, no, developing an algorithm is hard. But verifying is pretty hard, too. Because here's the thing. You created your amazing eating simulator. And you're going to post it on Steam. And it's going to be amazing, People like all these weird simulators. So eating simulator is going to be a big thing. You run it. And either you choke the first time you eat. Or the thing just, you're just frozen. You can't move. You're like, why can't I move? I can't move. It's like it's jammed. It's just shaking, shaking super fast. You're like, what the heck is that happening? Well, guess what? That is what we consider a bug. A bug is an unexpected action in the program that shouldn't happen, but it has happened, and it's due to some sort of logic error. And so that is going to be on your verify phase, where you're going to basically follow the steps and see what happened. Okay? There's also a verify when you're developing an algorithm by hand. So for example, if you develop this algorithm on paper, you can verify by plugging in some numbers in hand before you even start programming. Okay? So anyways, let's go ahead and talk about a little bit about the process of implementing your program. So we got the implement phase, and then we got the maintenance phase. The implement phase is, of course, making your solution, which is your program, and then testing it. If errors are found, you go back. So this is kind of I'd say it's a circle. So maybe put some arrows like a circle. So you create an implementation. You test it. You find that the eating simulator failed. So you go back and you try to fix something, change something, test it again. This time this worked, but something else broke. And you just keep doing this forever. And you probably will never finish because it's very, very hard to fix all issues in the program. And some of them you don't see now. You might see 10 years from now because somebody did something super, super, super weird that actually broke it. And that's what happens with video games. That's why developers have updates. Warzone has weekly updates, I think, because there's always bugs. There's always things that people will do that break it, and that's it. I think recently there was a thing with the dual revolvers that were super overpowered, and so that's a balance thing. That's not necessarily a bug, but it's something that they had to modify to make the game work better. These are all things that only come out with time, and so there's no easy way of actually figuring this out when you're first creating the game. No matter how much you verify by paper, until you actually run the program and you have a beta test and alpha test, do you actually find all these issues? So yeah, we like to call that phase the maintenance phase. And so basically you want to modify, so what I said, so modify to meet changing requirements. So yes, the requirements might change, like I said. People may start abusing some specific gun in Warzone, so they have to nerf it. But they also might just fix errors. Like there was an exploit where you could go under the map and with a helicopter or something. So yeah, it's an exploit. Or just a hard crash, some program crashes that are found during normal use. Now, this doesn't have to be a video game that you're running here. Let's talk about Microsoft Word, since most of you are probably familiar with that. So, Microsoft Word, what could be something that they may want to modify the requirements? Well, let's say the Microsoft Word has a dictionary, right? They can spell check. Suppose that there's a bunch of new words that are coming up into popular speech, like the word meme. Me may not be in the dictionary before, but probably it's now. So they want to update the dictionary in Microsoft Word spell check software so that it doesn't detect it as an error. This is a changing requirement you're adding to the program by adding to the dictionary. Errors that you may find. Well, suppose that whenever you write a paper on Microsoft Word, let's say that every time that you do a page break, the program uses a little bit of memory that doesn't release. And we like to call this a memory leak. You'll learn more about them in 202. Maybe it's a bug somewhere in the code. And it's very hard to detect because the only way people see it is if they're writing really big papers, like they're writing a book or something. And so they might not find it until somebody actually tries to use Microsoft Word to write a really long book. And bam, now we found an error that wasn't visible during the original creation of the program, and now we're gonna fix it. I am teaching 202 Summer 3 actually, so yeah. That's gonna be a lot because I gotta do 219 as well. So anyways, I'm gonna go ahead and move on now. We're almost done with all this stuff and then we can start programming. But before we can start programming, let's talk about the three main types of programming languages that you will run into, okay? So, first of all, let me put a nice definition of what a programming language is that is from the book. And I'm not gonna test you on definitions usually. I don't think I do. I usually just make you code stuff. But it is good to know this definition. I will probably, okay, I take that back. I will definitely ask you what the different types of programming languages are. But I'm not going to ask you to define like super specific stuff. A programming language is a set of rules, symbols, and special words used to construct a computer program. I like that. Okay, so we'll just leave that there. Okay. So the types of programming languages, all right? How about we continue with some designated? I can teach those too. I don't know. I taught it last semester, or sorry, no, I taught it a year ago in person in the fall, and before that I taught it as well. So I think that was 2 semesters in a row that I taught it. So I don't know if I don't know. I have no idea what I'm teaching. I mean, I was supposed to teach 302 in the fall, and now I have no idea. So. No one knows, but I'm pretty sure at some point ever again I'll probably teach it. But yeah, I think we peaked last time I taught it though, so I don't know how I will do better than that. That was good times. I missed them. Okay, so the 3 main types of programming languages that you should be aware of are going to be the machine language, assembly, which may bring some PTSD to the people here who have taken 218. And of course, high-level language. Yeah, triggered. Okay, so let's actually start with machine language. So machine language are instructions made up of sequences of zeros and ones. That's what they are. Just binary, as it's called. So binary means 2. And it's because we have only zeros and ones. And everything is made up of zeros and ones. And the way you do it is a specific combination of zeros and ones stands for a specific instruction. And those are instructions that the computer can understand and directly execute. And an important thing here is that they are machine dependent. Okay? Machine languages are machine dependent, and what that means is that instructions that I write for your computer with your specific hardware is going to be different than instructions that I write for my hardware. The obvious example being an Android phone versus a desktop. They're completely different architectures. One is using what is it called? ARM processors, and other ones are using x86 processors. So, but even within x86 processors, there's different kinds of processors and they have different instructions. And I'm talking about like an i7 5th generation is going to have different instructions than an i6. i7 6th generation. Now, most instructions will be the same because they're not going to just flat out change everything. That'd be horrible. But they usually add extra instructions over each generation of Intel processors, usually to make it more efficient. Sometimes they add like encryption things and whatnot. So, but ultimately, because of that, the instructions are going to be machine dependent. So if I was to write a program in machine language, it would look literally just like this. And it would just be a bunch of that. And that is because in the computer, this specific combination of zeros and ones, one standing for electricity flowing, 0 for a gap of electricity within sort of a wave, that stands for specific instructions, such as turn this LED on, and so on. If you want to know more details about how binary works with a basic CPU, CP100 and CP100 Lab is where they talk about that kind of stuff. So you can take those classes or Google about that. Ask all the CP noobs in the chat. So yeah, okay. So these are going to be your instructions that are directly understood and executed by the computer. Okay, directly understood and executed by the computer. Said it multiple times because I didn't want to write it down. Okay, assembly language. So here's the thing. I don't know about you, but I don't want to write code like that with zeros and ones. That'd be horrifying. You know. Horrifying. Noob is the CP100 people. But yeah, that'd be horrifying to write programs like that with zeros and ones, because like I would have to have a big table next to me that says that this combination of zeros and ones stands for this specific program. So because of that, we come up with assembly language. Assembly language are going to be instructions made up of a word that I have to write down before I can pronounce it. It's like mnemonic or something. M-N-E-M-O-I-N. Whatever. I can't even say it out loud. There we go. So it's mnemonic. I think that's how you say it. Okay? And that is like in the move EAX the word cancer. Because what it is assembly is... they basically take machine language, and instead of having to remember all these zeros and ones, they're going to give them specific, supposedly easier to understand keywords to do the same thing. So for example, one of these instructions might be to move from one register to another register. Registers are going to be your little memory bits inside of the CPU that hold the information that is being processed. Let's say you have 2 of them, and you're trying to move data from one of them to another one. You say something like move from register 1 to register 2. Okay? And within the registers, there are different sizes, blah, blah, blah. But anyways, that's what you do. It might just be like this thing. That is exactly what that does. However, I don't like that. So instead, I'm going to go ahead and do like what I said, which is move EAX D word cancer. What that means is move to the register EAX, the D word, which is a quote variable, I think, named cancer. I think. Again, my assembly is rough. If there's one class that I will avoid teaching, is assembly because I would have to actually really relearn that stuff. But anyways, yeah. So I feel bad for the people that get to 18. But hey, it's good to know. Just don't forget it. I took it and I forgot everything. So I'm sure it'll come back easier now if I was to retake it or sit in on it. But yeah, instructions. Instructor. I wrote that wrong. Instructions. Okay. So here's the thing. The assembly is still going to be machine dependent because all it is the same thing as machine language. However, we're using something more readable to us. Like it's a lot easier to remember the keyword move and EAX than it is to remember the combination of zeros and ones. Double word size variable. Yeah, D word. Yeah, so there's different sizes, and I believe double word is 64-bit. I guess. I don't know. Maybe. But yeah, so to convert assembly language into machine code, which the computer can read, you need an assembler. But an assembler is just a direct translator. It's going to take this thing and just automatically switch it to something else. It may not be a one-to-one correlation, but it's very, very close. Okay? it's still painful to write code like this because it's so low level, and that's not an insult, that's what they actually call it, low level, because it's very close to actually what the computer is doing, that it's super burdensome to write any program. Like, I try to write a program like a basic calculator, I gotta write this nasty assembly stuff because I gotta really go mathematical. Oh, we're getting a little bit of lag. Okay, we're good. We're back up again. Good. You have to really get to the, like, you know how I was saying with the instructions of eating? This is way more low level than that. Like, this is to the point, like I said, where you gotta actually send an electrical impulse for a certain amount of time, which as a result will move a certain joint a specific amount of degrees. And whereas in a high level language, you'd be like, move finger 5 degrees up. In the assembly, it's more like servo 5, send electricity for 5 seconds, which represents a movement of hopefully 5 degrees or something like that. It's very burdensome to do that. It is, of course, there's the one good advantage of coding in assembly is going to be that you can make things super efficient because you're controlling exactly all operations that happen. And if you go in there and you just code everything directly in assembly, you can make the most possible efficient program in terms of space and time. So whenever you're writing something like a driver or something that like a keyboard driver or a mouse driver, you want it to be super fast. So you really want to go and optimize it to the maximum. That's when you go into assembly code. You don't do that when you're just trying to write a basic program like Warzone. In fact, I'd be surprised if anybody, when they were coding like a video game, they go into the assembly. The drivers that are involved for the controller are definitely in assembly, and maybe some of the engine stuff that Warzone's running under, they did on assembly, but I'd say 99% of the code is going to be not written in assembly because it would take decades to write that much code in assembly. So because of that, we have high-level language, where instructions are closer to a natural language. And by the way, I think I said this already, but you will learn, if you're a CS major or CPE, I think you got to take it too. You got to take 218, which is assembly. You get to learn assembly there. Word is, it's one of the hardest classes you will ever take, so be ready. You definitely want to make sure you're prepared for that. Commit to it. It's a great class though. It's great. All right, so high-level language is closer to natural language. It's also machine independent. With a little bit of a disclaimer there. That means that if I write a program in my computer, I can run that program in your Mac, which is using a different architecture potentially than mine, or in the Linux machine if I was using a different CPU or whatever, and it should still work okay, for the most part. It's not always the case, but for the most part. We call that machine independent. Is that true? Was coders that couldn't make entirely out of assembly? That's hardcore. Oof. Ooh. I'll have to Google that later, because oof. Damn, that's hardcore. That can't be true. That's insane. Why would somebody do that kind of thing to themselves? I guess they wanted to make sure it ran smooth. What are some examples of high-level language? I guess I should put some examples of this. So this is, like I said, x86, ARM, MIPS. High-level language examples are, of course, Pascal, Java, Python, JavaScript. What other ones did you guys mention last time? I guess SQL is technically a high-level language. I think those are all the ones that you guys mentioned that you had experience on. Of course, the one that we want to make sure that is in here is, of course, C++, which is what we're learning in this class. We're learning a high-level language. We're high-level people. So, yes. That's a high-level language. Okay? So here's the thing. How do we convert this high-level language? Because that's not something a computer understands. It understands machine language. And You know you can convert assembly language into machine language with an assembler. But how do you convert high-level language into either an assembler or a machine language? And it turns out that you can do it with a fancy dandy program called compiler, which is a class that you will take at the end of your degree, 460, taught by none other than the man, the legend, John Peterson. John Peterson, not John Peterson. Sorry, that's because we have a student in our class called John Peterson, so you threw me off. Matt Peterson. I wonder if you guys are related. You have the same name, like the same last name almost. But no, probably not. Let me just write this down and also take a verbal break. This is probably the day where we write the most. Once we actually get to programming, there's not this handwriting, this whole coding. So, you know, we're almost over with this stuff. 2 years. With the remaining 1% written in C. But why? The real question is why he did this. Was it because he could? You know, he was so preoccupied with whether or not he could that he didn't stop to think about whether or not he should. Was that? That's interesting. I'm gonna have to read more about it too. I mean, that's hardcore. Maybe it was like a project for him to learn. But yeah, some people just want to watch the world burn by writing an assembly code. You know, imagine debugging that. Like, geez, like debugging assembly like at that level. That's insane. So, all right, you guys earn my respects for if you ever do something like that. But anyways. So a compiler is a program that translates instructions written in a high-level language into machine code. So it's going to take your high-level language, natural language style writing, and put it into machine language or assembly language, either or. But it doesn't matter because then once it's an assembly language, you can make it into into machine code by throwing it in an assembler. Here's the catch, though. That conversion is not always 100% efficient because of, you know, there's a lot of ways you can translate something. It's almost like you're trying to translate from one language to another. You're never going to have an exact representation of things, you know. And if you do, it may not be the most efficient way to do things. There may be useless instructions or unnecessary instructions, which make the code bigger or slower. But that is the price that we pay to not have to write an assembly. And frankly, that's a bit. I'm okay with paying that price for the rest of my life. Like that's perfectly fine, and that's what pretty much everybody will say, except for apparently the Mr. Doom Blaine, so who wrote the or Sawyer, sorry, not Doom Blaine. Doom Blaine's the village. Sawyer, who wrote the Tycoon and Assembly. You know, most people will not go that way. Most people will just write a high-level language and take the efficiency cut. Here's the other thing. Compilers nowadays are pretty darn good to the point that you don't lose that much efficiency by writing in a high-level language. It's not like you lose half the efficiency or something. It might be like now this is me guessing, but it might be like a 5-10% efficiency loss. Maybe, if even. It could be even like less. It could be 1%. What you definitely don't want to do is you don't want to try and write efficiency plus code and try to override the compiler in that. Trust the compiler that it will be making the code as efficient as you can. Okay? So ultimately, I'd say just do high-level language and take the efficiency cut. Leave it for those who are writing the super nice libraries that you get to use, not in this class, but in the future, to actually go in assembly and try to make a quick sort faster or those kinds of things. You don't worry about that. Okay. So that's my spiel about compilers. It's an entire class, so you'll hear more about it when you take 460 by Matt Peterson. Dr. Matt Peterson. Okay. Two more definitions that I just want to throw in here. We have source file or source program. And then we have object file or object program. FYI, a source file is what we call a program written in a high-level language. So when you submit your assignments, the .cpp file, that's called the source file. Okay, that's what you're submitting. However, when you compile that, you convert it into a machine language version, which we like to call the object file. Okay, don't turn that one in because I can't look at the source code for that. I have to reverse engineer it and no. So you want to make sure that you turn in the source file. So I guess there's another very beautiful diagram in the book that does this. Maybe I'll take a screenshot for next time or something, but if not in Tool 2, they'll show it to you. But you got your high level language, which gets converted into assembly and or directly into machine code. And so this is going to be your source files, potentially. However, in this class, they're all going to be these here. And then this is your object file. That ./a.out, ./a.out, that's your object file. The hello.cpp is going to be your source, which we also like to call the source code. And I also like to call that the executable. That's more of a Windows term back in the day. Okay, final thing. This will wrap up chapter 1 actually of the book. Is what we like to call the problem-solving technique. This I covered back in 302, but I even when I taught 302, I said that it might have been mentioned in 135. So I guess I should mention it in 135. And that is the problem-solving techniques. What are some problem-solving techniques when you're trying to write a program? These are easier said than done, to be honest with you. But first of all, ask questions. So if somebody tells you to write a program, the first thing you want to do is you want to ask questions and make sure you understand all the specific details. And this includes your homework assignments. Ask questions if something isn't clear. Next, to understand it better, try to see things that are familiar. Okay, solve it by an analogy. Recognize the problem if you've solved it before and use that to adapt your solution to the current problem. So if you've written the program to do to play a video game, for example, I gave the 302 students a video game to code CSGO in 2D, right? But when I was coming up with that problem myself, in the past I had done a Fortnite game, which I might give you guys, again, I'm debating on recycling that assignment for this class. But anyways, basically, that assignment, the Fortnite assignment, is very similar to the CSGO assignment because there's still top view, player movement, shooting, and that kind of thing. So I took the solution from the Fortnite assignment and used that as a template. I still coded it from scratch. Actually, might have used maybe like 1 or 2 functions, but I coded it from scratch because I wanted to clean up the code, and this was an opportunity to do that. But anyways, I use that as a basis because I had solved a lot of things of how to do that from that, such as how to make player movement, how to store the data in an object-oriented programming. Oh, did we die? Hold on. Class over, boys. Livestream's over. Oh, hold on. It will come back. Yep, the Gigablast internet. Okay, I think we're back. Yay. Sorry. That's what happens. Now you guys experience it in 135. I have the highest tier of internet available, which is the Gigablast. And I still have like third world country. Actually, no, that's a lie. Because in Mexico, I have better internet than here. So I have first world country internet, which is 60 megabyte download speed and 35 megabit upload speed when I'm playing for a gigabyte. But such as life. I have fiber in Mexico and I can't even get fiber here. So sad. It's the country that we live in. So we're all back, right? There's a huge delay. Refresh. Hit refresh and maybe that'll help. I actually tried switching to CenturyLink, but they don't offer it in my house. Like literally, like I live and across the street they offer it. To the left they offer it. To the right they offer it. I'm literally like in a black zone. Or is that what it called? Black zone? Or whatever. void zone. I don't know. So yes. Okay. All right. So I'm just gonna go back in. I don't know what the last thing I said that cut off. I think I was talking about the problem solving technique. So I'll just kind of go from there again. So the first thing you want to do is you want to recognize an analogy. So ask questions, I guess. So for example, like I said, I was working on the Fortnite assignment, and when I was creating the CSGO assignment, I looked at the Fortnite assignment. I said, there's a lot of things I can use from this to this. So I used that to solve the problems there that I would have otherwise have to do from scratch. You also want to identify any I/O happening, like in to out. What is your input that's expected and what is your output? And that way you can identify what your program should do and what it needs to take, so that you can sort of map that process out of converting input into output. Other useful strategies known as divide and conquer. Divide and conquer is the idea of breaking a large problem into smaller problems that are easier to handle. We are behind for 5 minutes. Are you guys? What I can do is I'll stop the stream and restart it. How about that? Okay? So I'll write it in. I will stop stream and restart. Okay, here we go. Refresh the page. Oh, okay. So do I need to do that? Oh, okay. Then I guess we'll keep going. All right. Just to tell you how much of a delay is, I can actually watch here. Nah, whatever. Do you get paid for the ads? I don't think I do actually. So yeah, you gotta install AdBlock. You can see how much of a delay is because you can see it up there, right? So okay. Yeah, it works with Twitch. I don't ever get ads. Use AdBlock Plus. I'll show you after the class is over if you want how to get that going. Don't watch ads on Twitch. That's but anyways. So divide and conquer. You want to break big problems into smaller ones. That's a very, very popular thing in not just programming, but in general. You know, it's easier to solve smaller problems, and more importantly, it's easier to test them. Okay, when you got a problem and you're trying to solve this problem, you know, you're trying to say, okay, I want you to write a calculator. Don't just write a calculator. Instead, write the multiplication function or the multiplication ability of the calculator. Test that out, make sure it works, and then parallel to that, do the division, addition, and subtraction. And once you know all four have been individually tested, then you can put them together and create your calculator. If you just try to like throw everything in at once, it's a lot harder to test, higher chance of errors, a lot harder to fix and debug. Another approach to doing this is building blocks, which is kind of what I'm doing, similar to divide and conquer, which is build pieces of your program and then put them together and sort of build on top of that. So again, for example, when we're coding the CSGO assignment, it was like the first thing I wanted to do was make a map. Then I wanted to have players that move around. Then I wanted to have the ability to shoot. Then I wanted to have the AI. These are all steps that I build, but I don't need to have an AI to just have the working map. I don't need to have the ability to shoot if all I want to do is test if I can move. So you build on top of each other so that you can more easily resolve problems as they appear. And of course, finally, you want to merge your solutions if you have already solutions to easier problems. Like if you need to do something that involves sorting data, but you've already done sorting before, you can just take that, throw it in your program, and sort of merge it in. Okay, that concludes chapter 1, guys. So that's very good. Now we can actually jump into programming and not have to do a bunch of lame stuff. But before, the last two definitions that I want to throw in here, big definitions, and I don't know why I'm obsessed with them. I think I've asked them in every single test in 135, 202, and even 302, and heck, if I get my way in 219, I'll ask it too. These two words, I love asking them on tests because I think they're very important, and for some reason people confuse them a lot. In fact, Gucci, I think, confused them in 302, which was sad. That's the one question he missed, I think, in the test. I hope he's not here right now. So, okay, but yeah. So, and those are the two big words So this is now chapter 2, I think. Syntax and semantics. Yes. Yeah, good job. Syntax and semantics. What is syntax and what is semantics? All right. Syntax are the grammar or rules of a language. Trying to make this super clean. Let me put a line here. Say chapter 1, chapter 2. Okay. So they are the grammar. She did grind them into your head. I'm glad. They gotta be grinded because there's people. I mean, imagine getting that wrong in Trio 2, syntax and semantics. Like the heck. But yeah, they're very different things, I suppose. So I'll put a line, visually separate them. And then on the other side, semantics is the meaning of the instructions. In the language. So this is the logic. Okay? Often called logic errors. So, okay. As you will learn C++ with me, syntax is going to be, obviously C++ has a very specific format or style to it, okay? I'll show you a hello world program in just a minute here. But you will see that that it requires a lot of very specific things. Oh, you took CS140, you take it with Eric? I'm actually curious now. Let me know. Yeah, oh cool. I'll ask him about you then. I don't know who you are, but just oh gosh, this class might be boring to you then, because I mean we're not gonna go into. I mean I guess hopefully it's not boring because a lot of this stuff may be repetitive from 140. CS 135 and 140 are supposed to be almost interchangeable. So I mean, you know, it'll be easy at least. So okay, we go a little bit more advanced than he does though, but he does do some fancy things with Python that we can't do off the top of the hat. So anyways, but yeah. I'm glad he has learned from me that he must emphasize those things. I told him to make sure he did. So yeah, syntax is going to be the rules of the language which say, you know, you have to put a semicolon at the end of each statement or at the end of each line in C++. That's a rule that has to happen. Just like in the English language, at the end of every sentence, you have to put a period and you have to capitalize the first letter of each sentence, right? These are syntax rules. Like, you have to do that. If you don't do that, it is a grammatical error, and if you're in an English class, they will deduct points, right? So that's a syntax error or a syntax related rule, that you have to capitalize the letter of the first letter of each word. Or for example, you also have to capitalize the first letter of a word that is a name of a person. You have to capitalize their name in proper English, right? Another rule is, for example, that you have to put a question mark at the end of a sentence that is inquisitive, or an exclamation point for an exclamative sentence, or exclamatory sentence, not exclamative. What other rules do we have in the English language? You have to put a space between each word. That's important too. You can't just like splash everything together. You put a space between each single word. Okay? What other syntax rules do we have in the English language? Well, if you're listing a couple of things, you put a comma between each of them. That's a rule too. Okay, now let's switch over to the semantics or the logic. Semantics of a language are errors that are grammatically correct, but there's still errors in the meaning. So that's, for example, when I'm talking and I screw up what I'm saying, and technically it's correct English, but it's incorrect in terms of meaning. So suppose that I wanted to say, I like cookies, because I'm trying to say that I actually like cookies. Like, I'm trying to tell you that I like cookies. But I end up writing, I don't like cookies. And that's what I write. Why did I write I don't like cookies? Because I made an accident. I wrote the word don't. Now, both of them are correct. So I'll actually write that here. So you know, I don't like, how do you spell cookies? Oh shoot, hold on. I think it's two. I always get confused which one has a double letter. Oh, of course, YouTube is useless. Okay, so it's 2 O's and 1, yeah, okay, cookie. There we go, thank you guys. So, yeah, okay. So, I don't like cookies, plural, I guess. Okay? And so, this is grammatically correct. Like, this is 100% grammatically correct. Whereas, if I wrote something like, I don't like cookies, like that, that is grammatically incorrect because I am missing a apostrophe there and I have extra E. Both of those are syntax errors. However, I don't like cookies is grammatically correct. However, if what I was trying to say was that I actually do like cookies, me writing the word don't in there is an accident. I am giving the wrong meaning to the instructions to the computer. So if I was trying to tell you that I like cookies, but I ended up writing I don't like cookies, then you think that I don't like cookies. Oh yeah, thank you. So yeah, technically that would be a syntax error. So very good. So yes, and I suppose let's make sure you guys don't get confused with the capital I. Okay, so semantics is an error in the logic. Syntax is an error in the grammar. Here's the thing. A compiler translates high-level language code into assembly code or machine code. However, it's very nice because it detects any syntax errors. And why? Because if it's a syntax error, it doesn't know how to translate it. So you can catch all syntax errors at compile time. Of course, you don't want to have them, but if you do, it will tell you, like missing semicolon, like you're missing a period at the end of the sentence. That would be literally the compiler telling me that, and then I can fix it. However, the compiler does not catch semantic errors. And therein lies, you know, what somebody posted on Discord, which is, give him a program, make him suffer for a day. Teach him how to program, make him suffer for a lifetime. Because therein lies your suffering. With semantics, it's impossible to verify at compile time, which means that if you make a mistake, you won't see that error until you're running the program. And because it may be such a rare occurrence, that you may never see that error until the worst possible time. And so therein lies the origin of bugs. Bugs are typically going to be, pretty much always going to be based on semantic errors. Okay? And another term for that is logic errors. Oh, and I can't write anymore. It just died. Oh, maybe ran out of battery? Yeah, the pencil just died. And that was just flashing Apple Pencil when I connected. Don't worry, I have a backup pencil, but still. Let's try it again. Yeah, pencil is dead. Anyways, okay, I think that's good enough on that side. I will reinforce on the semantic and syntax next time. Let's jump into coding then, because that I can still do, unless my keyboard doesn't work. So let's go ahead and get in coding. Let's go ahead and do hello world. And then we can go back to the, I was going to give you a little bit more definition on a C++ program, but we can do that next time. I can actually type it here, but you know, it's okay. All right, so where's my thing here? Let me switch over here. All right, cool. Not white, you know. I really gotta change the background. White is just painful to the eyes to see, so maybe I should change the background. Nah, Eric is not that great. But you know, I was really trying to push him to give you guys more homework, but he kept refusing. Like legit, I literally was like, no, make it. He's like, no. Like, come on, give him NumPy, and he's like, no, they don't have the linear algebra background to do it. I'm like, nah, just do it. But he just would not budge in to give you guys more work. But it's okay. I mean, you learn, so that's what matters. Okay, so welcome to Linux. Linux, this is, in fact, before, here, I have an idea. I'm going to first show you what Ubuntu looks like in general by showing you this monitor. And then turn that off. Okay. Snap you guys away. Why? All right, so this is what Ubuntu looks like. And I'll switch over back to the big one later. I just want to show you a quick overview of what Ubuntu looks like if you have a VM. Ubuntu is an operating system, okay? It's an operating system that that works like Windows and Mac. It's more close to Mac than it is to Windows. And some basic operation of it is, I guess, here is the power button. You can click shut down. If you're using a virtual machine, I have both VMware and VirtualBox. Right now I'm running VirtualBox. You want to make sure that you copy some of these settings down. I'll read them out loud because they're tiny. Base memory, you want to up to most of the memory you have. Put about half the processor power you have. Make sure you put acceleration on, 3D acceleration. You give it video memory. That will give you much better output. Okay. But anyways, once you actually start the installation process, you can watch a tutorial or whatever. But once you got it running, a basic thing you got to know is you can close a VM by pressing the X here, and it'll ask you whether you want to save the machine state. In that case, hit yes or okay. That will actually, how do you fill up the whole screen of the VM? Mine's like a box. Oh, good question. Yeah, so go over to view and adjust auto resize guest display. I think it's this one. It's one of these two. I think it's this one. So click that. First of all, make it big. It'll be just a black box there, and then hit that, and it'll extend it. And if you're in VMware, it says fit guest now. Okay? So yeah, just do that, and then you're not gonna be you're working with a little tiny thing. That's painful. But yes, go ahead and try that out. If you have problems, let me know. But yeah, okay. So if you want to shut the computer off, you do it this way. But typically, you just want to save the state. If you save the state, the next time you turn the computer on, it's going to be back in the VM in the same exact spot. Great, good job. All right. So okay, cool. End curses. What else I want to show you here? Here's files. The home directory is usually snaps. This is all the people that I've snapped before. So your home directory is where your files are going to be located usually under your username. You got your desktop like a Windows or Mac, your download folder. You can create folders, all the same thing. You can right click on them. You can go to properties. You can see any details you want. You can get errors as well. That's kind of scary. Oh no, this thing's like blowing up. Okay. I think I'll just move that to the side. It won't close. So yeah. Let's just hide that away. How do you go to device, insert guest add-on? Oh yeah, you definitely want to insert guest additions. Yes. Like I said, there's tons of, Google this stuff and you will find tons of people helping you out. But yeah, other than that, the terminal icon is this. You can also right click. Yes, of course, hide it, hide it down here. I don't know what this is. I've seen this before. I think I'm not kidding. If I spam this enough, it'll actually go away. But yeah. Okay. So, you can right click here and click new terminal to open the terminal window. You can also right click anywhere and click open terminal, and that'll actually open it, I think, in the directory. If you don't see the menu open terminal here, Google, and it'll tell you. What else? Visual Code. Let me show you Visual Code. But for that, I'll switch over to the monitor. But anyways, this is what the main desktop would look like. I, of course, have multiple monitors set up even within the VM. That's the only reason I was using VirtualBox today, because VMware doesn't let me do multiple monitors. It's kind of weird. But yeah, so let me switch over to the one. Okay. So now let me bring this down here. Okay, cool. All right. So we got 20 minutes. That should be good enough to get a little initial program. Oh, we got lag again? Yeah, probably. Yeah. While that happens, let's go ahead and open this up. There we go. It'll come back. Just to give it a minute. It's coming back now. Nope. It's I have a, for those of you not aware, I have a monitor here that tells me the kilobits per second. And right now it's at 3 kilobits per second. Now it's at 400 kilobits per second. Once it hits about 2000, we should be back online. It's going to 800 now, so it might be coming back. Now it went to 200, 98, 101, oof, 0. In the meantime, maybe the tablet thing came back. Oh, it works again. Cool. Even the ad is being weird. Tell me when it comes back up. I'm just sitting here waiting for it to come back. What sucks is we got 20 minutes and I really wanted to come back so that I can get through the Hello World program. Oof. Oh, I think it's coming back. Oh, okay, cool. Yay! You know, it's kind of sketchy that it goes away for that time, like for the right amount of time for an ad. So that's kind of suspicious, you know. But, yeah. Okay. Yay, I'm back. Okay, cool. All right. So, yeah, I don't know. It's weird. Yeah, now I get, like, tons of uploads. So that's kind of sketchy, like how it goes away. It's super sketchy. So I don't know. But anyways, we're good now. We're good. Okay, so let's just go back in because we got 18 minutes and I want to really show you a basic program. So okay. So all right. So let me walk you through the most basic Linux command instructions as I remember them. The first one being, of course, how to open a terminal window. You right click and click open in terminal, okay? And that'll open up a terminal window like this. Okay, so now you got two terminal windows open. So let me actually use that one. Now, first command, how to look at the contents of your current directory. You can type in ls for that. ls will show you all the contents. So if I had more than one thing here, so maybe I had a file called rename. Why can't I type? That's okay. We'll make a file manually by hand. That's okay. All right, some sketchy, weird things are going on. Okay, so, all right, let me show you how to make a file, a text file, okay, with a terminal. You can use gedit if you're, or Visual Code, but let me just show you the terminal version. So you type in the keyword nano, which will open up a text editor, okay? However, you can also put the name of the file you want to either edit or create. So I'm going to create a file called myfile.txt, okay? So I type in nano myfile.txt, press enter, and it's going to open up a text editor. And here I can type like, hi, this is my first ever Linux file. Don't forget to like and subscribe. Okay. All right. And when you're done with that, then you want to save it. To save it, you can see on the bottom here all the different instructions you can do. The little hat symbol represents the control key on your keyboard. So if I want to close this, I can do Control X. Control X, and it's going to ask me, save modified buffer. I want to say yes or no. So I press the Y key, and the moment I press it, it's going to ask me which file I want to save it as. It's already going to put in there the name of the file that I put in when I launched Nano. If I had launched Nano without putting a file name in front, then it would be empty and I can type it in. If I want to save it under a different name, I can do that right now by just type it in. But in this case, I'm going to use the same name. So I don't have to push anything. I just push enter. And bam, if I look at the directory here, I can see now that my file has been created. And I still can't delete the untitled document one, or can I do that now? No, I can't do that. That's weird, sketchy. In fact, let's try to delete it using the terminal. So I can press LS again to see my contents. Now you can see my file there. How do I delete stuff? Let's try to delete this weird untitled directory thing that I did. You can use the RM key for that. RM, and then you put the name of the file. Untitled document. It worked. Yay! So we can delete that weird cancer. Okay, let's go ahead and also delete. Let's go ahead and copy my file and make a duplicate of it. I'm not forcing them to use. No, I'm not. I'm just showing you Nano because it's the one that I'm used to. So first of all, let me show you the copy command. So suppose I want to copy my file into my file too. Okay. So here's the thing. CP means copy. Now here's the thing. You don't have to manually type in. And I've seen 135. I've seen 202 students do this, and it triggers me. You don't have to type by hand the entire file name. You can press the tab key and it'll autocomplete. Now, if you had something with two different file names, like this, I said my fail.txt. So in this case, I'm going to copy my file, or here, hold on, my file.txt into a new file called my fail.txt. Okay? Press enter. You can see here that I copied the file, so I'll leave it like that so you can see what's happening. And now, if I was to go ahead and try to remove one of them, and I push M, and I press tab, it'll only autocomplete until the part where there's multiple. If I spam tab a couple of times, it'll give me the options of what I can do. So I can then maybe go ahead and say fail, and then I can delete my failures like this. Bam, failures have been deleted. As you can see, it disappeared. I can also confirm on the terminal. So we got copy, let's do move. So let's go ahead and make a directory actually first. How do you make a folder? You can use the MK there, and then folder name. So let's go ahead and say we want to name our folder toothbrush. Okay? So you type in make there toothbrush. I do recommend that you keep all your folder names lowercase and no spaces so that less can. Like you saw how Untitled document has that weird slash. That's because there was a space. Delete your fails in Ubuntu. Yes, I have succeeded that. So that thing is still there, by the way, in the other window. But yeah. Okay, so I press enter. As you can see, that makes a folder. I can confirm that by looking with the LS. Notice that this color coding may change, but usually if it's color coded, there's a different color for directories than there are for files. In my case, the files are white and the directories are blue. But I think that that changes depending on the terminal that you're working on. In fact, if I was doing Ubuntu on Windows 10, I think the colors would be different, like red. So how do I delete a directory? Let's go ahead and, but before I delete it, let's go ahead and copy, or let's move the file into the directory. So I can use the move command, mv. nv my file into toothbrush. Notice the slash because it's a file, and then I can use either the dot, which will copy the file with the same name, or I can specify. Yes, all these commands are the same when you're using PuTTY because you're connecting to Linux, to Sally, which is using all of these. So these commands work in those. They will not work on the Windows terminal, but they will work on when you're connected to the Linux server. On Windows, like some of these commands vary, but there's similar commands there, like there instead of ls for showing the directories. So anyways, if I do this, it just moves it with the same name. I could also copy it over with a different name, like my file.txt. And that moves it back. So let me go ahead and move it again. Oh, this time I tried to move it, but it complained because there was no file called my file because I changed the name, right? So I can do my files.txt. So now if I go ahead and click inside here, you can see that there it is. I can also go ahead and delete it while it's inside of the folder. So I can do rm toothbrush. Let's just delete the entire. Well, if I wanted to delete the file, I could do it like this and just press enter. But let's go ahead and delete the entire folder. If I just try to do remove toothbrush like this, it's gonna tell me that it cannot do it because it's a directory. So in that case, I want to do rm-r and then toothbrush. Okay? And bam, the entire folder is gone. Now somebody does ask, what happens if I do rm-rf? Shall we try? What do you guys think? Should I press enter or should I not press enter? Yes? Do it for the memes. All right, I'll press enter. Bam, I press enter. Nothing happened. Why did nothing happen? Why? Nothing happened, guys. I wonder why. Well, that's because I think they actually, you have the sudo in front of it. I wonder why nothing happened. I think it's because I have to put the double dash. I think I have to do sudo for it to actually delete everything in the computer. But anyways, don't try that at home. Don't try to do rm-rf at home because that will actually delete, like, I believe it'll delete everything in your computer, in your Linux machine. So yes. So there you go. A live demo of doing rm-rf. Don't be scared of what you read on the internet. I wonder why I didn't do anything. I thought it would give me a warning saying like, don't be dumb, but it's just like, nah. As you can see, it's still okay. So yeah, don't be scared. It's safe to do, but don't do it still. Okay. Now, if I did sudo rm-rf, that's when things get a little scary. So yeah, okay. No, I don't think it's frozen right now. So anyways, moving on. Let's see, I showed you CP, nano, ls. By the way, you can do ls-a to see some details like hidden files. Anybody can think of another Linux command? CD, yeah, CD, that's a good one too. I probably was using that and I didn't even think about it. I don't know. Okay, so suppose that you want to go into a directory. You do CD 1. That'll take you inside of the one directory. There's nothing there, but I can go ahead and make a file. Nano file. Hi. Control. Yes, save. Now I can do ls. Now it's there. So I can do CD to go into a file. I can also do CD dot dot. That will bring me back a directory. I can do it again. It'll bring me back a directory. Now I'm in my desktop. I can go back in by saying CS135 1, and that'll bring me 2 directories in. So CD is very, very useful. Thank you. That's the big one. Clear is useful too because it clears the screen. And that brings us into 2 options here. I can either show you hello world or I could show you SSH. Let me very briefly show you SSH. To SSH into the servers that we have, you put in your username and then you put either Sally or Cardiac. Use Sally though for this class. Cardiac as a backup. You press enter. Change that with your CS login. Put in your password. Okay, and then I'm gonna do something here because I'm smart. By the way, when you type the password, you don't see it. That's okay. It's still putting it in there. I'm hiding something because I don't want to show something. Yes, I'm smart. So, when you log in, it'll say Department of Computer Science, student servers, report issues to problems, blah, 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 email CS help, and then it'll tell you last login, the date that you last logged in, and the IP address of the last logged in. The reason I'm not putting my IP address up on the screen because I don't want to get DDoSed. So, yeah. But you can type in clear and it goes away. Okay, so that's how you SSH. You can do log out and it'll kick you out. So when we actually code the entire stuff and we want to send that to you, how do we send it and compile? Yeah, so to send a file back and forth between you and Sally, you use SCP for that. SCP works the same way as CP. CP being the copy command, except in this case, you know, if I wanted to if I wanted to copy file, I could do cp file, file2, and it copies file, right? SCP is the same way, except in this case, instead of putting file2, I'm going to go ahead and put the entire log in. So like fonseca8@sally.cs.unlv.edu, colon, and then just put a dot, and it'll send it to your home directory, or you can give it a name, file2. But this is the easiest thing. Do that, and then press enter, and it's going to ask you for your password, and you're good to go. In this case, yeah, why not? Let's do it. Let's just send garbage to my directory. Why not? Bam. It tells you 100%, and if it was a big file, it would be a timer here. How to bring it back? Let's bring it back from the dead. All right. CSP file, same thing, except now this time you're going to do it the other way around. So I'm going to put sally.cs.unlv.edu, colon, then the file name. So I think it just called, what did we send it as? File. Yeah, file. And then I could put a dot, but I want to give it a different name. So back from the dead, or back from Sally. Press enter. Put in your password. And did it work? Yes, it's back from Sally. So it traveled all the way to UNLV, interacted with Sally, and has returned from his journey. So yes. Okay, so that's how you do SSH. Okay, so here's what you should use instead of don't code in Nano or Vim. Don't code in Vim in general, but or Emacs. I mean, yeah, you can be hardcore, but I personally like to use Visual Code. So let me go ahead and, because we got five minutes here. So let me just make a file called hello.cpp. Okay, I have a file called hello.cpp. And now I can just open it with Visual Studio Code. The reason I did that is because I didn't want to go over here. But you can also open Visual Code and create a file that way. Yes. Make sure you run your code on Sally by doing the SCP thing. I can code it here, send it. I'll show you probably next time because we're about to run out of time. But I'll show you how to send stuff back and forth as I just did, but actually doing it on a real program. Okay, so this is what Visual Code looks like. And now I can go ahead and write code here, and it'll color code it. So I'll tell you more about what this is later. But this is a program. Okay. At least now it is. I think it should compile. Gasp, what did I do? There we go. I was trying to use the shortcuts. Okay, so Control S to save. So now I can save that. I can go ahead and pop open my terminal again. And so there's my program. So I can do G++, which is the compiler. And then from there, I can go ahead and just type in g++.hello.cpp. If there are no errors, then it should not give you an error. If there were errors, syntax errors, then it'll tell me that there's an error like that. We'll talk more about that later. I just want to very briefly give you that crash course on running. It keeps minimizing my OBS, so I can't see if you're looking at it. Here we go. Okay. So if it just compiles, nothing happens like that, that's a good sign. To run it, ./a.out. I usually just put in the dot and the slash, and then just, well, I guess I put the A and then put the tab so it auto-completes. Run it, and voila, it runs the code. There are other IDEs and other programs to use to develop code. This is just one of them. Feel free to use any at your convenience. Visual Code is just a text editor, actually. How to install Visual Code? Sudo apt-get install Visual Code, maybe? Question mark? Huh. I don't know. You have to Google what the command is, but how you install things in Linux is you do sudo apt-get install, and then you put in the name of the package. I can't remember how I installed it. We can Google it or something. But yeah, okay. That's the lecture, guys. It's a 2-hour lecture, but I mean we covered an entire chapter, so this is my first ever summer class. So hopefully we're on track. So we'll see. First for me too. Why can't I see the? We do have the chat overlay. So you guys just finished your first day. You didn't really get to code much, but you got to learn a little bit of the background. I know it's boring. You should. I mean, don't feel bad. I think when I taught 135 last time, it actually took the entire week to go over what we did today. So I think we're about on track. So yeah, I wish we could do pointers tomorrow. Writing the assignments for 135 without using OOP stuff is just painful. But yeah, I went ahead and made all the homework assignments public except for one of them, which I'm still working on and deciding if I want to do. I was going to do an asteroid chase game, but I think I might just do the battle royale game. I don't know yet. So yes. Any questions before we end the chat? I'll be on Discord. I'll be up. I mean, I just woke up, so I don't work at 6 p.m. So I'll be up. I can answer questions and walk you through a bunch of stuff. But I wanted to end the video recording because I already have to upload like a 20 gigabyte video to YouTube. So yeah, I mean, most people teach in Emacs. So yeah, I know. I just showed you like 20 commands in Linux. You will definitely have to probably watch that piece of the video again to remember them. But you know, it's just practice. Yeah, nah, I don't know. It's not a real game. That's why. When we start going to the 9 a.m. time. Okay, so if we decide with the 9 a.m. time, probably like either Friday or Monday, I will tell you guys. But what I did is I created a poll on Discord so you can choose the time. So if you prefer a different time than 9 a.m., just vote there. Otherwise, I'll just go to the 9 a.m. time slot. So yeah, just vote on that poll. That way I can appeal to most people's time zone. 11 a.m. I mean, it's just a 2-hour time slot. So just vote on the poll, and I can use the statistics on the poll. Yeah. So I am in Vegas. Yes. I think we got like a massive spam, but I think that's pretty much everything. So, all right, guys. Oh, that was an accident. So, I guess I'll see you guys tomorrow at 7 p.m. until further notice that we change the times. For now, get some rest. Try out some of the things. If you want to be dangerous, go ahead and try out the first homework assignment. I'll check the syllabus and figure out what's up with the quizzes on there. And like I said, I'll be on Discord, so stop by, chat, get some help if you need. If not, then I'll see you guys tomorrow. With that. Bye. And don't forget to turn in that syllabus thing.